Let's now discuss the influence of opens and shorts inside series circuits. Opens are breaks with infinite resistance through which no current can flow. Shorts, in contrast, are zero-ohm paths around other elements through which current can flow. Let's first examine the influence of opens in series circuits. Consider the series combination of a 510, 390, and a 220 ohm resistor. Ordinarily, this circuit would have a total resistance of 1,120, or roughly 1.1 kiloohms. If, however, there existed a gaping hole between the first two resistors, the total resistance of this series path is now infinite. This is an open circuit through which no current can flow. Due to the inclusion of the open, the source effectively sees an infinite resistance because no conductive path exists. Consider a rearrangement of this same series circuit, this time including a gaping hole between the last two resistors. This is again an open circuit through which no current can flow. Due to the inclusion of the open, the source effectively sees an infinite resistance because no conductive path exists. In summary, an open anywhere in a series path completely severs that path. It makes sense. A series or inline path with a rupture or open anywhere in that single path does not have a conductive path. Functionally, opens in series circuit can take the form of switches, the status of which controls the fundamental on or off state of the complete circuit. An open switch anywhere in a series circuit halts all current flow and de-energizes the complete system. Conversely, a closed switch allows current to flow and energizes the system. Let's now deal with shorted elements in series circuits. A short is a low resistance path around or in parallel with an element. Consider a 510 ohm resistor with a 0 ohm wire in parallel or around the resistor. Think about it. When presented with a 510 ohm path or a 0 ohm path, through which would a majority of electrons travel? Undoubtedly, the 0 ohm short presents a far easier means of travel from end to end. All current will be routed around the shorted resistor. The shorted resistor effectively presents a 0 ohm resistance path. As previously, consider the series combination of a 510, a 390, and a 220 ohm resistor. Ordinarily, the circuit will have a total resistance of 1,120 ohms, or roughly 1.1 kiloohms. If, however, we included a short or 0 ohm path around the 510 ohm resistor, all current will be routed around the 510 ohm resistor. Thus, the total resistance of the series path is now only the series combination of the 390 and 220 ohm resistor, or 610 ohms, implying that the shorted 510 ohm resistor is essentially excluded from consideration. If we return the 510 ohm resistor to its original configuration and short the 220 ohm resistor, the source effectively sees only the series combination of the 510 and 390 ohm resistor for a total resistance of 900 ohms, implying that the shorted resistor is essentially excluded from consideration. All current will be routed around the shorted 220 ohm resistor. In summary, a shorted element in a series path removes only the shorted element from consideration. Before we bring this lecture to a close, consider this oddity. A circuit consisting of 4 resistors, only 3 of which present a complete series path, the fourth just dangling out in space. How does the source see this combination of resistors? To answer this question, think how current travels through this circuit. Any source current leaving the positive terminal of the source must travel through the 510 ohm resistor, through the 390 ohm resistor, and through the 220 ohm resistor to reach the negative terminal of the source, implying that no current travels through the 100 ohm resistor dangling out in space and can be effectively removed from consideration. The source still sees the series combination of the 510, 390, and 220 ohm resistor for a total resistance of 1,120 ohms, or more appropriately, roughly 1.1 kiloohms. In summary, resistors must be in the single path to be considered part of a series circuit. Series circuits are inline configurations of resistor through which current flows end to end. All right, that's about it for today. In conclusion, this lecture took a look at series or inline configurations of resistors. We learned resistors in series add up and discussed the influence of order in series circuits, identical resistors in series circuits, abnormally large and abnormally small resistors in series circuits, and the influence of shorts and opens inside series circuits. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.